morning, everyone. Today I'm gonna be looking at it's Unit 5, which is diodes. So the goals for this unit, I just want to look at let's say different types of diodes. Remember, in the previous lessons, we managed to look at the theoretical aspect of diodes. So today I just want us to look at the types, and then I'm also going to talk about the characteristic curve. Characteristic curve. Purpose of this curve is to describe the relationship between voltage and current, right? And then also I'm gonna be in a position to explain the operation of Zener diode and light emitting diode, right? So like I said, in the previous chapter we managed to look at the definition of a diode, a semiconductor operation, and how electrons move from one side to the other side. So for now, we just want to go deeper and look at a typical diode and other types of diodes. So, what is a diode? A semiconductor diode. A semiconductor diode is a two-terminal PN junction device that has a low resistance, which acts as a closed switch when forward biased, and a high resistance, which acts as an open switch when reverse biased. So this is to say, if you were to make an analogy, if you look at a tap, you're gonna be using a tap to control the flow of water. So with a diode, it's actually a similar function. It has a similar function. You just want to control the flow of current. That's it. So if it's forward biased, then you know that current is going to flow through. Meaning it's more like a tap that is open. You understand? Okay. So, but if you've closed the tap, that's why now we use the term reverse bias, meaning the tap is closed. There's no flow. You understand? So I hope you understand that analogy. So like I've said, I've actually explained the analogy using words. Is there a way that we can explain the analogy or the operation of a diode using a graph? Of course. That's where now we come to a characteristic curve. So characteristic curve, you've got yourself your x-axis and your y-axis. So on the x-axis you've got your voltage, and then on the y you've got current. Understand? So that is to say, once, let's look at the first quadrant. Remember we spoke about forward bias. Just gonna use forward FB, right? Forward bias. And then let's look at the relationship between voltage and current. So if you're gonna be describing that graphically, then you notice that you're gonna have something like this. It's increasing. As time goes, the voltage will increase and also the current will increase. You understand? If it's forward bias, meaning the tap is open, there's a flow of water. In this case, there's a flow of current, and also there's a flow of voltage. You understand? But then if you look at the reverse bias, you're gonna be describing that using the third quadrant. So in this third quadrant, we've got negative voltage, and we also have negative current, meaning everything is just negative in this quadrant. So you're gonna have yourself a curve like this, that goes like this, something like that. So meaning your current, there's no flow of current. Tap is closed. Understand? So now I want us to look at a symbol that we use for a diode. Is there a way that we can use? Remember, like in engineering, we like to draw symbols. So is there a symbol that we can look for a typical diode? Of course, you've got yourself this kind of symbol. So this symbol represents your basic diode, and then you have yourself, can you see, this is more like a K but facing in the opposite direction. So K for cathode, C, and then here it's your anode. Understand? So remember, like I tried to explain the basic operation of a diode. How do you know that a diode is forward biased, and how do you know that it's reverse biased? That is to say, if you're gonna take your battery and connect, let's say I'm gonna use a symbol for battery. This is positive, this is negative, right? So if you're gonna be connecting your negative to the cathode and then positive to the anode, then remember current flows from negative to positive. So you're gonna be having water, in this case, is current flowing in that direction. Meaning it will be forward biased. It's going to allow current to flow if it's like this. So negative connected to cathode and then positive to anode. Do you guys understand what I'm just saying?
Yes, sir.
So sharp. But then what happens if you decide to reverse the polarities of the battery? Then I'm gonna make this positive and then I'm gonna make this negative here. So can you see this is negative, this is positive, right? So I'm going to reverse everything. So current flows from negative to positive, meaning it's gonna go in that direction. So if it flows in that anti-clockwise direction, then can you see this is cathode, this is anode? Then there won't be a flow of current in this case, meaning you guys are gonna be looking at this pattern graphically. But then in terms of words, then you know that you say this diode is reverse bias, meaning there's no flow of current in this case. Current should always follow from A to C, anode to cathode, not C to A. You understand?
Yes.
So that's the basic operation, right? So we just actually explained forward and reverse bias using words and then graphically, and then I was just trying to draw a symbol and stuff like that. I hope you guys are okay with that.
Yes.
Okay, sure. But then here comes the question. Okay, I haven't tapped into different types of diodes yet because I want to dive deeper into what is actually a diode and then basic application of diodes, right? So what's the fascination about this thing? Like, where do you actually get this this component? So if you're gonna be looking at your home, you have yourself a charger, you got your TV, your radio, whatever case may be. All those devices that you guys are going to be using, they have diodes. So diodes, a diode can be used as a what? As a switch. Understand? So that is to say, this actually brings us to the concept of rectification. So rectification is nothing but the process of converting alternating voltage to unidirectional voltage. Meaning if you're going to be looking at your wall outlet, power that's going to be coming out of this wall outlet, it's AC, it's alternating, it's not DC. So DC, that is to say, is just moving in one direction, but here it's alternating. It goes back and forth. Understand? So you don't want to be using AC for your charger. You need DC. Understand? So with that in mind, you need to be using your diode to chop out current that's not needed in that case. You understand? So that is to say, let's look at now the types of rectifier circuits. Okay?
Yes, sir.
So you have yourself half-wave rectifier and a full-wave rectifier. So half-wave rectifier, remember now in the previous lessons we discussed transformers. You know if you have yourself a transformer, and then you saw the time we did that experiment where you connected a transformer to the wall outlet, and then the transformer is going to step down the voltage. So with that in mind, we can just, remember this is your primary side, this is the secondary side. Primary side is the one that goes to the wall outlet, and then secondary side you can connect it to whatever components that you want to connect it to. So in this case, let's start by connecting one diode on the secondary side. So remember, the main function of this is just a switch. It allows current to flow in one direction. So here, a transformer, you're gonna be having like an input I know I'm too quick, but if you were to describe the behavior of the voltage, it's more like a sinusoidal wave, a sine wave. So an alternating current is represented in this manner. It's alternating. You've got positive, and then negative again as it continues, right? So this is the type of voltage that's going to be flowing through the secondary side as well as the primary side. But then with this device, your diode is going to chop out, it's going to remove the negative side. Remember, it only allows current in one direction. If this is positive, this is negative. Your diode will only be interested in positive. It won't allow the negative. You understand? So this is to say now, this is your input, and then you have, they call it IPO, input process and then output. So we've got the input here, your voltage is alternating. But then the process, what about the process? Process is your diode, the function of a diode which allows, it chops out negative voltage, right? So your diode, which is the process, you're gonna get something like, remember, once it goes to negative, this guy won't allow, and then you have something like this. Understand? So for this positive, yes, we're going to get this graph, and then for the negative, it's not going to allow it because it's moving in the opposite direction, so it's just 0 in this case. Once it becomes positive, you drop it as it continues. So this is your output curve, but then the process itself is done by the diode. Is it fine?
Yes, sir.
Okay. So that's how you actually